Hello everyone. Today we're going to look at a problem of how to find the current in each resistor of a multi-loop circuit. And we're going to do that through using Kirchoffs rules. So right away, I'd say maybe pause the video and look at what I have written down here because this will be pretty useful in deciding how to solve the problem. So I'd say pause right here as well as right here. And then after you have all that, maybe go through this problem with me. So if this is our actual question, find the current in each of these resistors. The way that I would start is with step one, create a junction rule. So this is one of Kirchoffs rules, and it's basically I in, so the current going into a junction equals the current going out of a junction. So the sum of the currents in equals the sum of the currents going out. And it's completely arbitrary which way you draw your currents in your loops, but these two guidelines right here are what I follow. So the current generally goes from the small end of the battery to the large end of the battery. And I would also say start with the largest battery because it produces the strongest current. So the largest battery is this 30-volt battery right in the middle. And I would draw the current, let's just call it anything. I call it I1 going down from the small end to the large end. Okay, and then once it gets to this junction right here, it's going to split into two different currents. So let's just follow this right path, and this current is going to make its way all the way around this wire until it reaches this junction. So let's just call this I2. And the same goes for this current. It's going to go all the way around the wire until it gets back to this junction. And let's call that I3. So let's focus on point E. So at point E, the currents going in is I1, and the currents going out are I2 plus I3. So this is our junction rule right here. Okay, and let's move on to what I would start with for step 2 is create your loops. Okay, and what I did is I labeled each corner in each junction of this circuit a different letter. That way it makes it easy to see which direction your loop is and what the loop actually is. So for this circuit right here, you have this left side. So that this left side, A, B, E, D, could be one loop. And this right side, B, C, F, E, could be another loop. Or you could use the total circuit. So you could go from A, B, C, F, E, D back to A as a loop. So the two loops that I used actually were loop A, D, F, C. So I actually used the whole loop, the whole circuit. So starting at the top left, going down all the way to the right, back up, and all the way back to the left. So let's start with this loop. Now pick any point on the loop. Let's just start right here. And the loop I have is A, D, F, C. So we're going to start at A and move to D. So it's going to look like this. Right there. So this is our loop direction then. Okay. So if you look back to all of these rules that I have laid out here, what is happening when we start right here at this arbitrary point and go down through this battery. So when we go down through the battery, well, actually, this is what the loop rule is. So the sum of the voltage gains equals the sum of the voltage losses. Okay, so when we go down through this battery from the large end to the small end, we're going to have a voltage loss. So that was a 10 volt battery. So you write that on the loss side. Okay, and now let's keep moving. So we reach D. Okay, we keep moving. We reach E, we reach F, and now we reach this 20 volt battery. So when we go through this 20 volt battery, we're going through it the correct way, so to speak. So on the gain side, we write 20 volts. Okay, now let's continue moving. Now we get to point C, and then we hit this 4 ohm resistor. So I2, the current passing through that resistor, is in the same direction as the loop direction that we picked. So in that case, we're going through the resistor the correct way, which means we have a voltage loss. So 4 ohms of I2. So on the loss side, we're going to write plus 4 I2. Okay? And we get to point B, and then we get to this 2 ohm resistor. So we see here that we have a little different situation. The current I3 is pointing to the right, but the loop direction is pointing to the left. So we're going through the resistor, quote unquote, the wrong way. So 2I3 is going to be a gain, like that. So this is our equation for loop ADFC. Okay? And now let's pick another loop. My other loop is just A, B, E, D. Okay? So using the loop rule, let's pick a place to start at. So A, B, E, D. Now this loop is going to be directed like this. Okay, so let's pick another arbitrary spot, just right there. So starting at this point, moving in the direction of the loop, we hit this 2 ohm resistor. So the 2 ohm resistor, the current is going to the right, the loop is going to the right, so we're going through the resistor the correct way, and that's going to be a voltage loss. So 2I3, just like that on the loss side. Okay, now let's keep moving. We keep moving, we get to point B, and then we go down, and we go through this 30 volt battery. And we're going through the battery the correct way. So that will be a voltage gain. So on the gain side, we write 30 volts. Okay, and we keep moving. And then we get to this 10 ohm resistor. So at the 10 ohm resistor, we have I1 directed downward, and our loop is also directed downward. So when the loop direction and the current are directed in the same way, we're going through the resistor the correct way. So 10I1 is a loss. Just like that. Okay, and let's finish. So we continue going, we go from E to D, back up to A where we started, and we go through this 10 volt battery. So our current I3 and our loop are directed in the same way. We're going through the battery the correct way. So that is going to be a gain of 10 volts. So plus 10 volts, just like that. So now we have two equations. Let's see. We have this equation here, which contains I3 and I1. And for our first loop, we have an equation that contains I3 and I2. So the currents that are common in these two equations, right here and right here, are I3. So because we have those common currents, we want to solve for the other one, whichever one that is. So starting with our first loop, we want to find I2. So we can subtract 10 volts over. So we have 4I2 equals 2I3 plus 10. And then to isolate I2, we can divide by 4. So I2 equals 0.5 I3 plus 2.5. So now we have an equation for I2, right? And going back to our second loop, we want to isolate I1. So 10 I1 equals 40 minus 2I3, and then we can divide both sides by 10. So we have I1 equals 4 minus 0.2 I3. So now we have an equation for I1. So now that we have these two equations, we can relate them back to what we did in step 1, which was forming a junction rule. So if we have I1 equals I2 plus I3, we can just plug these in here, just like that. But let's first rearrange this a little bit. So I3 equals I1 minus I2, like that. So plugging in I1, I3 equals 4 minus 0.2 I3 minus what we have for I2. So if we're subtracting I2, we have 0.5 I3 minus 2.5. So now this final equation that we have here, one of our final equations, everything is in terms of I3. So we only have one variable, one current. So we can start to isolate I3. So we can add 0.2 I3 over, and we could add 0.5 I3 over as well. So that will give us 1 I3 plus 0.2 I3 plus 0.5 I3. We get 1.7 I3 equals 4 minus 2.5. So 1.7 I3 equals 1.5. And then we could divide each side by 1.7. And we get that I3 equals 1.5 divided by 1.7, which is 0.88 amps. So we have figured out I3, and this is good. We can relate this back to how we started. So if we said I3 is this current right here, it is the current that's going through this 2 ohm resistor. So that helps us answer our question. The current going through the 2 ohm resistor is equal to I3, which is 0.88 amps. So let's continue to solve for I1 and I2. And it's pretty straightforward now that we have I3. We can go back to our equations and we can plug in different values. Plug in the value of I3. So for our equation of I2, which equals 0.5 times I3, so 0.5 times 0.88 plus 2.5, this will give us I2. So I2 equals 2.94 amps. Okay, so we have I2, and that is the current going through this 4 ohm resistor right here. I2. Okay. And let's continue solving. So for I1, it equals 4 minus 0.2 times I3, so times 0.88. We get that I1 equals 3.82 amps. So now I1 is the current going through this 10 ohm resistor right here. And this makes sense. So I1 is produced by this 30 volt battery, this large battery, and it is the biggest, it's the largest current. Okay, so our answers make sense, and they also follow our junction rule from earlier, which is I1 equals I2 plus I3. If we were to take I2, which is 2.94 amps, plus I3, which is 0.88 amps, we would get I1, which is 3.82 amps. So that also is a way to check our answer and make sure we solve the problem right. Alright, thank you for watching. This is how to use Kirchoffs rules to solve a multi-loop circuit. Thank you.